Welcome back, my aspiring mathematicians. We are getting ready to take a look at solving one-step equations. We are joining the legions and legions of x's, looking for their values. When you solve an algebraic equation, the goal is to isolate the variable. Well, depending on what you think about when you think about isolate, we need to define this. This means the variable has nothing added, subtracted, and it has a coefficient of positive 1. Even though we don't write the 1, the only thing out in front of it could be a +1 if we chose to do it. When we have this goal, our only options are using inverse. That's a fancy way to say opposite operations. So, very, very quickly, let's take a look at our possibilities. We could have adding or multiplying in our equations. Their inverse operations or their opposite operations are subtracting and dividing. Anytime you see one of those operations in a problem, the only way to undo that operation is to perform the inverse or opposite operation. So here we go. We are going to solve for the variable. Solve means isolate the variable. Now, one of the things my students have found helpful in the past is to put a line through the equal so that they have a visual barrier between the two sides of the equation. I think this is a great idea, especially if you're just starting out. Now, our goal is to isolate that letter V. Well, there is a thing standing in our way. That thing is that 8. Now, there is obvious addition going on right here in the middle. That sign actually sticks with the V. The 8 has its own plus sign sitting out in front of it. Math people are just lazy though, and we don't write it. So what we need to do is move this 8 so it's not with the V anymore. Since this 8 has a plus sign in the front, we need its inverse operation. The inverse of adding, or being positive, is subtracting. If I do it on the right side of the equation, I have to do it on the left side of the equation. Now, what I want you to notice is that I'm only subtracting it in one place on either side of the equation. I have had some students in the past who want to subtract 8 from the V and 8 from the 8 and -8 from the 26. Don't do that. That's bad. That will give you a one-way ticket straight to math heck. You can only subtract it in one place on either side of the equation. Now, I know that positive 8 minus 8 is 0. I haven't touched the v, so we're going to bring it down. If you need Desmos, I have jumped on this soapbox before and I will do it again. I may even say it louder for the people in the back. If you need a calculator because you stink at mental arithmetic, plug it in the calculator. I cannot say that enough times. Plug it in the calculator. Now, normally in math, we don't write 0 plus anything because it takes up time and it doesn't change the meaning of our statement. So instead of 0v or 0 plus v, we are just going to write v. 0 plus the thing is the thing itself, equals 18. Now, sometimes it makes me feel a little off when the v is on the right side of the equal sign. If that is you, you always have the option to rewrite it with the variable on the left side. But you better make darn good sure that you have not changed a sign when you flip it around. Make sure the v is still positive. Make sure the 18 is still positive. Moving on. This one exists because as teachers, we know that you guys don't like negatives. So of course we throw them in there. Okay, I have built the wall between the two sides of my my equation. I want to isolate this n. So I know my goal. Now, the object that is standing in my way is this pesky negative 15 right here. And I'm really not like him because he is negative. He's a very grouchy person. He's also odd. Grouchy, odd people don't get to stick around very long in my life. Anyway, I need to move this grouchy number 15 to the opposite side of the equation. But since he is negative, I can only move him, I can only make him relocate and go bother somebody else if I use his inverse operation. Well, the inverse operation for being negative is adding. If I do it to one side, I have to do it to the other side. But I only do it once per side. Now, I know that negative 15 plus 15 is 0. I'm going to bring down the positive n because I didn't do anything to him. Negative 9 plus 15. Guys, if you stink at positive and negative numbers and you cannot remember your sign rules at this point in the game, go get the calculator. Negative 9 and 15 gives me 6. Now, we are all math people. You may not think you're a math person, but you are a math person. Because number one, all you have to do is be a person. Check. You have to do math. We're doing that right now, therefore you are all math people. Math people are inherently lazy, so we don't write 0 plus n. We just write n. So that means our n value is 6. Now, y'all, this is really cool. So bear with me a minute. This equation, this negative 15 plus n equals negative 9, there is only one number in the entire numerical universe that you know about that makes this equation a true statement. And you guys just found it. That's cool. For this one, I'm going to set up my wall again. Now this time, I still have a barrier for isolating n. N has a 16 added to it, but I don't want that 16. I want that 16 to get out of my way because I have things to do. The only way I can remove a positive 16 when it is n plus 16 is by using the inverse operation. Positive 16 and negative 16 combines to 0, so I'm just going to have an n on the left side. If I change the last thing that I entered into Desmos, the lazy way, the lazy way didn't work. I get negative 7. And I have found the only number in the entire numerical universe that makes that equation true. Uh-oh. Now, wait a minute. This one looks different. I don't care if it looks different. Start off just like we did the other ones. Build your wall. Now, this one, you're correct, looks very different because this time the operation between my variable and its coefficient, that's a fancy name for the number in front of the x. I think in front is probably 2 words. The coefficient is the number in front of the variable. This time, our coefficient is a positive 8. Now remember, anytime you have a number that butts right up next to the variable, especially in the front, the operation is understood to be multiply. Well, I don't want an 8 in front. I want a 1 in front of that. Remember, long ago in a galaxy far away, we said that a number divided by itself was equal to 1. So if I can get this number divided by the right number, I can get a 1 right there. Well, I know division is the opposite of multiplication. If I divide both sides by 8, your math teachers in the past have used this term called, they cancel out, called the cancel out property. Yeah, guys, that's not a real property. It doesn't really exist. Here's what's happening. I'm going to get rid of this and we're going to go on a brief but very informative field trip. So here goes our little field trip right over here. It's a quick trip. Didn't even have to pick snacks. I have 8x over 8. Well, this is the same as 8 over 8 times x. Well, by now you guys are pretty smart. You know, because you were paying attention about 42.5 seconds ago, that 8 divided by 8 is 1. Well, wait, that's what we were looking for. We wanted a positive 1 in front of the x so that we could say the variable had been isolated. That's all we needed to do. And now you know what the canceling out property really is. It's creating a clever 1 where we need it. Now, y'all, I don't know, negative 104 divided by 8. So I go to my handy dandy Desmos calculator and I find out that x is equal to negative 13. Now, when I write my final answer, I don't have to put that 1 up there. In math, if you don't see a 1 or a number in front of your variable, it's understood that it's a positive 1. So I'm going to leave it just like it is. Now, this one is yet again slightly different. This time, we have y divided by 18. Some people say this as y over 18. That is totally valid as long as you recognize that y over 18 means y divided by 18. Well, here's the thing. I still want to isolate the y. So I need to use the inverse operation for multiply. Well, the opposite of divide, I think I said multiply before too. I want the inverse operation for divide. The opposite of divide is multiply. So I'm going to multiply by 18 on both sides. Now here comes our field trip again, so pack some snacks. Because we are not going to use the cancel out property since it doesn't exist. We are going to do the math at least once for why this works. So you have y over 18 times 18. Well, I could write this as y over 18 times 18 over 1, because I can put any number over 1 and turn it into a rational number or a fraction. When you multiply fractions, you multiply straight across. Eighteen times 1 is just 18. This is the same as 18 over 18 times y. Well, if you were paying attention ago, about 2 minutes and 37 seconds ago, to be exact, we talked about how any number divided by itself was a 1. So this is a 1 y. We just don't write the y or the 1 because we're lazy. So through all of that magic on our field trip, we end up with a y on the right and whatever 18 times negative 6 is on the left. If you like the variable on the left instead of on the right, again, feel free to rewrite it. Just make sure you don't change anything besides the direction. Now this one has a negative 10 as the coefficient for the x. Y'all, please do this just like the other ones. The negative doesn't matter. The operation gluing the negative 10 and the x together is still multiplication. The inverse of multiply is divide. We want to create that clever positive 1 out in front of the x, so we want to divide by negative 10. We know that negative 10 divided by negative 10 is that 1 we were looking for. 40 divided by negative 10 is negative 4. If you don't believe me, stick in the calculator. Ms. Graham, how do I know when I'm finished? How do I know that I can stop? You get to stop when there is an invisible positive 1 in front of the x, and there is nothing behind the x but an equal sign. There's no plus 2, there's no minus 6, there's no 12th power. It is simply an x, an equals, and then a number. This one is a little bit different because it does involve a 0, and for whatever reason, sometimes that throws people off. Don't let it throw you off. Y'all, this is still negative 15 times m, or multiplied by m. Continue to do the inverse operations. So if I want to do the inverse of multiplying by negative 15, that means I want to divide by negative 15. Negative 15 divided by negative 15 is a positive 1. I'm going to make my imaginary 1 in front of my m. 0 divided by negative 15. Y'all, don't tell me it's negative 15. It's not. It's 0. If you tell me it's whatever's in the denominator, or if you tell me it's anything other than 0, I'm going to yell at you for not using your calculator. The other ones on here, I was going to say they're the same. They're not quite the same. I'll do this one. We may not do the last one. I'm going to put my wall. I haven't used my wall in a little while, so I'm going to go back to it. This time, I have a negative n minus 8. Well, this one gets a little tricky because I need this to be a positive 1 with nothing else over there. So the first thing I'm going to do is move the 8. I need to do its inverse operation, so I'm going to add 8 to both sides. If I do it to one side, I do it to the other. This is negative n plus 0 is negative 2. But remember, we don't write the 0 anymore. Takes too long. I have no idea what I'm going to do with the extra 14 and a half seconds out of my day. But here's the problem. I want, remember, a positive 1 out there in front, and this is a negative. If you need to, put the 1 out there. Stick it in its spot so you can see it and you don't mess up. Now this is negative 1 times n. So I need to divide by the negative 1 so that I create that positive 1 as a coefficient for my n. Negative 1 divided by negative 1 is the positive 1 I'm looking for. Negative 2 divided by negative 1 is not negative 2. It's not negative 1. It is positive 2. That was a brief look at solving equations. Stay tuned because next time we're going to crank it up a notch.